Hello friends, I welcome you in lecture number 31 on graph theory. In this lecture we are going to have introduction of special type of graphs which are known as trees. We will understand the definition of trees in this lecture. So before going for the definition of trees, we recall the definition of connected graph which we have discussed in earlier lectures. When a graph is called connected graph. So if we recall, the connected graph is that graph in which there is a path between every pair of two vertices. If any two vertices of a graph are joined by a path, or if there exists a path between any two vertices of a graph, then graph is called connected. So we will remember this definition. Connected graph. Connected graph is that graph in which there is a path between every two vertices. And we will require another definition, which is definition of a cycle. A cycle is a path whose initial and terminal vertex are equal or same. And cycle is called simple cycle if all the edges in the cycle are distinct. If all edges in a cycle are distinct, then cycle is called simple cycle. So if you are familiar with these two definitions, then it is very easy to understand or remember the definition of tree. A tree is a connected graph. A tree is a connected graph with no simple cycles. If we consider undirected graph, then an undirected graph is called a tree if it is connected and it has no simple cycles. So very easy definition. A connected undirected graph with no simple cycles is called a tree, and connected graph means that graph in which there is a path between every pair of two vertices. Now we consider this remark that tree cannot have a simple cycle. By the definition, tree must have no simple cycles. Therefore, tree cannot contain multiple edges or parallel edges or loops. Hence, any tree must be a simple graph. Every tree is always a simple graph because it must not contain simple cycles. So using this definition, we can check whether given graph is a tree or not. All we have to check is that whether given graph is connected and whether it is having any simple cycles or not. If there is at least one simple cycle in a graph, then it is not a tree. And if there is no path between at least one pair of vertices, then that graph is not connected. Therefore, it is not a tree. So a tree is a connected graph with no simple cycles. So here I have taken 4 graphs and we will check whether they are trees or not. First we check for this graph G1. First I have to check whether it is connected or not. So I have to check for all possible pairs. I can have this type of pairs possible: AB, AC, AD, AE, then AF, then BC, BD, BE and BF, then CA, CB and CD and CE and CF. After that DA, DB, DC and DE and DF and then EF. I have to check whether there is a path between any pair of two vertices. So these are the all possible pairs. here order is not important because this is undirected graph. So first we check for this pair whether there is a path from A to B. So we can see this is a path from A to B. We can reach B and A from each other along this path. Then from A to C also there is an edge from A to C. Then from A to D we have this path. From A to E we can go from A to E along this path. Then from A to F we can choose this path. This is a path from A to F. Then from B to C we have this path. So this is also verified. From B to D. So we can go from B to D along this path. Then from B to E we can go from B to E along this path. So there is a path between B and E also. Then from C to D. So this is obvious path from C to D. From C to E we have to go along this path. From C to F we have this path. From D to E we have to choose this path. And from D to F we have to choose this path. And there is a path from E to F also. So we have verified that there is a path between any two vertices of this graph G1. Therefore it is connected. And we can see that there is no simple cycle in this graph G1. Therefore G1 is a tree. Graph G1 is connected undirected graph with no simple cycles. Therefore G1 is a tree. Similarly we have to check for graph G2. So we can check that whether there is a path from A to B or not. So if I want to approach B from A, then I can see from A I can go up to F and D, and I can go from A to C. I cannot go from A to B along any path, or B is not reachable from A. B is reachable from this vertex E. So there is no path from A to B. I cannot reach A and B from each other. You can see I can go from A to F, or I can go from A to D and from A to C, but I cannot reach B from A or A from B. So therefore this graph is not connected, and therefore it is not a tree. A tree must be a connected graph, and connected graph is that graph in which there is a path between any pair of vertices. So here for this pair we are having no path from A to B or from B to A. Therefore G2 is not connected, and therefore it is not a tree. Now we check for G3. It seems that G3 is connected. We can see that there is a path from A to B, then from A to C, from A to D also there is a path. There is a path from A to E also, and there is a path from A to F also. Similarly, you can check for all possible pairs as I have checked for G1, and you will find that this G3 is connected graph. You will see that there is a path between any two pairs of vertices in G3. So G3 is connected. Now I have to check whether there is any simple cycle or not. So I observe one simple cycle. Suppose I go from A to B and from B to E, then from E to D and from D to A. So I find one simple cycle. I start with A, then from A to B, from B to E, then from E to D, and from D to A. So this is a simple cycle in G3, and we know that tree is a graph having no simple cycles. Therefore G3 is not a tree because it contains one simple cycle, which is from A to B, then from B to E, then from E to D, and from D to A. So this is a simple cycle in G3, therefore G3 is not connected. What about G4? So here also we can see that from A to B there is no path. If we go along this and along this, then it is not connected. So let me check whether these two are same or not. These two paths are different. Here there is no edge from C to E. Here there is an edge from C to E. But we cannot reach B from A or A from B, because from A we have edge up to F, and from B we can go up to E or C. But there is no path between A and B, therefore this is not connected, and therefore it is not a tree. G4 is also not a tree. So in this way we can easily check whether given graph is a tree or not. What we have to check is that it is connected graph and it has no simple cycles. Another name is no simple circuits. Tree is a connected undirected graph with no simple circuits. So remember this definition of tree, and we will continue with this concept of trees in upcoming lectures. Thanks for watching.